Next, let's look at some equation solving. We're going to do equation solving of exponents, and then we'll get to logs after that. Just wanted to show you this Google shot we made of a slide. Mr. Server noticed that Bitcoin was changing its value, and it was 0 or close to it around 2013. Now it's up to 16,383 per Bitcoin, and it may be even higher now or lower, but if you look at this, this is a great example of an exponential curve. Not much happening until the very end, and then it just goes nuts. And you saw that with the microbe problem, is not much happened until that last 5 minutes, and then it just took off. Well, we're going to do some solving of equations, finding x with exponent right now, and I'm going to show you a few tricks, and then you'll use those to do some solving. Probably the easiest trick is to look at your bases. So in this case, my bases are exponents of each other, so you could call 4 2 squared to the x and keep 2 to the 3x minus 1 the same. So now you have 2 to the 2x equals 2 to the 3x minus 1. And in order for these to be the same, then 2x has to be equal to 3x minus 1. So 2x equals 3x minus 1 because the bases are the same. And so we'll have 1 equals 3x minus 2x. So x is 1. Now I like to try answer. So if I put 4 to the 1, is that equal to 2 to the 3 minus 1? Or is 4 equal to 2 squared? It sure is. Perfect. This one's a little bit tougher because what you have to do is you have to find out what exponent 5 is. So in other words, 5 is equal to 2 to the what power? Okay, so log base 2 of 5 is equal to x. So I checked it in my calculator. I took x and set it equal to the log base 10 of 5 over the log base 10 of 2. I got 2.32. 2.32. So if you look at 5, 5 is 2 to the 2.32 times 5x equal to 2 to the x plus 7. Now look how easy this is. Once I've done that, all I have to do is say, okay, 232 times 5 is 23.2, which is 11.6. So it's 2 to the 11.6x equals 2 to the x plus 7. So 11.6x equals x plus 7. And if you subtract x, I get 10.6x equals 7, and x is 7 over 10.6. Pretty amazing. Around 0.7, pretty close to it. So what I did is I fixed this so the base is the same as this, and then 5 is 2 to the something power. You figure that out. 5 equals 2 to the something power. Figure out what that is, and then write it. 2 to that power, and then 2 to the 5x. It all works out from there. Nice algebra. Okay. Let's do some additional solving here. E to the 2x minus 4e to the x. So I'm going to write this as e to the 2x minus 4e to the x minus 5. Okay, so let's do a substitution. Let's let e to the x be equal to w. Well, this is w squared minus 4w minus 5. And I bet if you saw that, you go, oh, that's a quadratic. So it's w minus 5w plus 1, and you get two cases. Either w minus 5 equals 0, or w plus 1 equals 0. And w, we said, was e to the x. So e to the x equals 5. Log base e of 5 equals x. The natural log of 5 is what x is. And then here, w is equal to negative 1. E to the x equals negative 1. Well, that is never. Can't ever happen. So x is the natural log of 5. Pretty cool. And you can do that with this one. E to the x minus 5 over e to the x minus 4 equals 0. What you might want to do is multiply everything by e to the x. So that's going to be e to the 2x minus 5 minus 4 e to the x equals 0. So then I would let w equal e to the x again, and you get w squared minus 4w minus 5 equals 0. And then factor it and solve. That's a pretty cool problem. These, kind of the same thing. If you have 2 to the x is greater than 2 to the third, you can say that x is greater than 3. You can do the same thing here. 2 to the x is greater than 2 to the 2.32. X is greater than 2.32. This one's going to be a little bit more effort. 2 to the x is greater than 1.5. You're going to need to turn this 2 to the x is equal to, I don't know what that is. It's 2 to the something. So it's going to be x is greater than whatever that something is using your calculator. Now they're just getting nasty. But no problem for you, because we're going to, if you can't use any of those techniques, call this y1 and this y2 and just see where y1 is bigger than y2. But graph those. Graph those. Put those in your calculator and say y1 is equal to 3 to the x. y2 is equal to x to the third. Put it in your calculator and see what places those are going to be y1, 3 to the x, bigger than x cubed. We could sketch this one pretty easily. Here's 3 to the x going through 0, 1, and here's x cubed going through this point, which I think is 3, because 3 to the third equals 3 to the third. And we want to know when the 3 to the x, or the purple, is greater than the, the green is higher than the purple. And it looks like green is higher than purple, x is less than 3. But you can use your calculator for that. And we can work on these. These are great practice ones, but it's kind of the same thing. So you're going to use your abilities to switch to exponent or log form when you get stuck. So, or get the same bases. Like this one's 2 to the 4x equals 8, which is 2 to the third. So you can get 4x equal 3. Do those type of things where you can, and then when you can't, use your calculator. These, what you'll want to do is cross multiply 50 e to the x plus 100. And you solve for e to the x. And then you can find out what x is. Good examples there. Great thinkers. And that's 8.2. exactly 10 minutes.